Hello everyone, and welcome to the first Gearify update in quite a while. I am Michael Valley, the creator of Gearify. I hope you are all staying healthy and safe in this really ridiculous time of human existence. I have a lot of cool stuff to show you. I've modeled this similar to a conference talk where I have about 20 to 25 minutes to talk at you. Um, Before you shuffle off to some other talk. So I'm going to try to keep it within that time frame. And yeah, we have a lot to cover, so I'm going to just kind of get right into it. All right, so here are the main topics I want to cover. New features, of course, the primary topic. Then there's user access, which is how you will get your hands on the software. The current development status of the software, as well as the upcoming pricing survey. So let's get right into new features. The new features of the next version of Gearify. First, probably the most important, involute teeth. I'll discuss the tooth editor, which is a very critical item that kind of brings all of the details together. A big surprise feature, which I'm very excited to share. The art gears, which have some special interesting properties, rack and pinion gears as well. Been needing to get those done for a while. Better exporting options. Yeah, whole bunch of stuff to give you. So let's jump right into the first topic. Involute teeth, the holy grail of the non-circular gear for me. This is by far the most requested feature for the original version of Gearify. I want to stress that these are not simply, your typical involute tooth that you'd see on a circular gear, just copy pasted onto a non-circular gear. You can actually come up with a generalization based on the law of gearing. And the next version of Gearify computes that generalization. But why do we care so much? And what's so exciting about these involute teeth? So properly designed gear teeth will induce a very smooth transfer of motion. That motion is actually modeled by the pitch curves, which is more or less the overall shape of the gear. You see here this animation of these pitch curves rolling together. This is the motion that you want to model. This is the relative behavior of motion, which is very smooth and very clean. It's a bit of a paradox in that, the gear, the theory of gearing, we spend all of our time sort of obsessing about how the teeth are designed, and yet the ideal gear has no teeth. But we have to do this because we live in a physical world. We live in actual reality. We don't live in an idealized textbook physics problem. So we have to talk about teeth. So ideally, the addition of teeth to these smooth pitch curves should not affect this rolling, should not affect the relative motion that's dictated by the smooth pitch curves, which are the gray lines in this animation here. The involute teeth should do no harm to this relative motion, and moreover, they should enforce this motion. And I don't mean kind of enforce it, but precisely mathematically enforce that relative rotation, just as the smooth curves rolling together. Now, in the old version of Gearify, it had more arbitrary tooth shapes, and it would induce, rattling and vibration. And literally, you can see it, you can hear it, you can feel it, the resistance. And the new version of Gearify with these new involute teeth, it's much quieter, much smoother. You can tell the difference. And to illustrate it, I'm going to now show you a video. All right, I think we can all agree that the difference there was like night and day. So these are much, much better suited for machining applications, these involute non-circular gears. So how did this, unfold, and how did I learn about these? Well, it was kind of an iterative process of, developing theory, which gave rise to software tooling, which led to more discoveries, which informed more theory. And this is sort of how the product matured. And in doing so, I learned a lot about the interrelationships of the parameters of these non-circular involutes. They're very, very nuanced. The variables are very carefully related. Not only can you vary the parameters, but you should vary the parameters from one tooth to the next, because that continuous variation is what non-circular gears are all about. But it's a big headache getting all these relationships right. So how do you manage all of these relationships as you're designing your gears? And the answer, of course, is with Gearify 2.0. It is a headache, but it's my headache. I get to have the headache so that you don't have to. You can cruise through and use a nice polished software product to do the job for you. That is the goal. That leads us right into the tooth editor. Now, after all this study, I performed, much tooling was developed to sort of manage all these relationships and give you the ability to adjust your teeth placement and sizing and pressure angle variation, all that stuff appropriately so that all the constraints are observed. And even when you do observe these constraints, sometimes you end up with tooth collisions and you have to sort of modify your design. So I give the user in my tooling the ability to sort of check and detect some of these tooth collisions, and then also suggest and allow you to make modifications to the tooth design so that you can resolve them. And all this tooling will be in the release solution. Here's an example: theoretically correct involute teeth, but there is a collision that you can see here. As I mentioned, the software will help you catch and detect these collisions, and it'll give you some options and some customizability to make the changes necessary to use the same desired pitch curve, but address these collisions. Here's some somewhat exaggerated examples for visual impact. You may not need to go this far, but one option would be to shrink the tooth size in some of these tight concave regions of the pitch curve. That pretty reliably resolves some of these collision issues when they occur. And furthermore, we have variation in pressure angle, which also can, by opening up the teeth a little bit more, a little bit wider, you can resolve some of these collision issues and get it to behave just fine. Another topic of great interest for me is continuously varying the pressure angle sort of more dramatically on a per tooth basis. Here you have a pressure angle varying from 20 to 60 degrees, and it's tracing out the tooth very nicely. This is, perhaps more like cyclo gears than involutes, but it's still a topic of great interest, and I'm studying how this sort of variation can be used to help you address some of these collision issues, and perhaps the software may end up smart enough to suggest this variation when necessary. So in the end, this tooth editor, which observes all of these constraints, became an extremely powerful sort of sandbox environment to be able to experiment with and vary and continuously vary all the parameters of the non-circular gears and their involute teeth. In fact, I suddenly realized that it had been so well parameterized that I could actually continuously vary the placement of the involute teeth along the pitch curve. And this gave rise to the ability to create a new type of non-circular gear that had never been supported by Gearify before. That's when the real mischief started. So rather than tell you about it, I will just show you what unfolded from there. Yes, yes, I like to be dramatic sometimes. So non-circular helical gears is what comes out of this. So you remember I showed sort of that conveyor belt animation. Um, represents a continuum of tooth placements. If you treat each frame in that animation of each sort of varying tooth placement as a slice in a sort of vertical stacking of many different gears that all share the same pitch curve but have a different sort of slightly shifted tooth placement, then when you stack them all up together is sort of this spiral-like tooth pattern. Now you need to use some spline surface interpolation to be able to, create a nice smooth continuum, and you need to use a fair number of sample slices, but you can do it. And helical gears are also a type of gear that have better mechanical advantages, which some of you may be interested in creating. So I'm very, very excited about this new feature, and tooling for this will be included. I also hope to include sort of this herringbone gear approach, which is the same thing, but kind of you take the same version and sort of mirror it back to back, and it creates sort of this V-shaped pattern, which can help resolve issues of there being like twisting forces between two gears, helps to balance things out, essentially. You will need to both compute and manufacture these quite accurately for them to work well. So a little asterisk on that. That will be important. But Gearify should support it. That is the intent. Rack and pinion gears. This is something I've been meaning to finish for a while. Involute teeth have been more the priority. Here's an example showed with the old version of Gearify. I didn't have any really good screenshots to give you at the moment. But this is what they, more or less what they would look like, only you would have involute teeth, and potentially I will support the helical gear arrangement as well for these guys. Arc gears. Now these are very interesting because so arc gears are basically when you take away the constraint that they have to be a closed loop, you just have sort of an open-ended segment. This would be something sort of mechanism that would probably oscillate back and forth. It would have to. What's really interesting about these is you can reverse the relationship between the designed tooth shape and the resulting power transmission variation. You can actually reverse the design process where you can start with, hey, I want the power transmission ratios to follow this curve function over time or as it rotates. And from there, you can actually deduce what the resulting gear shape should be. So that has some interesting, design opportunities there for engineers who are interested. Better exporting options. This is something I no longer want my users to have to, take a 2D design and extrude it in some other software product. I want to be able to directly export models in, STL, OBJ, maybe a few other formats, and also include things like, the hole placement and sizing the hole, as well as maybe some rudimentary base design support. Something similar to what I have shown here, which is what I used to build my helical gear model. User access, this is something I'm really excited about. So the new version is going to be a web app browser-based solution. I've done quite a bit of prototyping on this, and it seems to be going well. You won't have to anymore worry about getting a new license if you transfer from one device to another. If you just have your same user account, you can access it on any device that you want, provided you have an internet connection. And I do want to put emphasis on being able to design gears from your phone because it's perfectly achievable. A phone is just a mini computer nowadays. And here I actually have shown a gear that was calculated on my phone. And you can, visualize it and use little swipe gestures to pan and zoom around. And it's really very fun and exciting. Really quite a joy to be able to design gears on just your phone. I'm very excited to deliver that feature for you guys. Development status. yeah, what's going on with the actual coding of the product. Just quick update on that. So I will say it goes well. Development's going very, very well. There was a bit of a hard lesson learned. Early on in the project, I did a lot of the modeling of the various, curves, the pitch curves, and the involutes and various things that were computed based on a piecewise linear model, essentially, discretizing a curve into many tiny segments. That worked, but the amount of computation required was very high, and it didn't lend itself to very accurate results. I had to use an insanely high number of segments, insanely finely partitioned to get decent results. And I've been reformulating the theory based on sort of more spline-based modeling. And this is very, very promising, the results I'm getting out of this. They're very accurate, they're very quick to compute, leaps and bounds better than the old approach. That did cause a bit of a delay having to do this reformulation, was hoping to release, closer to this spring, but because of this reformulation, the expected delivery dates pushed back a little further. But it's very fast, very accurate. Early prototypes of the refactored design looking really, really awesome. Estimated completion for the refactored app is, probably, I say late spring, but at best late spring, probably closer to summer 2022. So that's what's going on there. Pricing. All right, now for pricing, this is an important topic where I need some feedback and some participation from my users. So it wasn't obvious from my humble surroundings. Gearify is a small one-man company. I am Gearify. This is it. This is all there is. This is all Gearify. Just it's me. I am not some large fat cat corporation. I am just an individual working on a project, and I need the continued support of my user base. The interest in non-circular gears, as probably most of you know, it does exist, but it's very niche. And I love this project. I would like to continue to expand this project, develop cooler and cooler capability for you guys. But I need a consistent user base, to fund the continued research, because I need to eat. If I'm gonna spend time on this, I need to eat. I need to pay my bills. So yeah, I heavily rely on your support. To that end, the new product will be subscription based, either month to month or year to year, something like that, where people who are continuing to use the software year to year, I will continue to receive some sort of funding and income from that user base. To that point, I need an honest assessment from you, my user base, on what the software is worth to you. So I will be shortly, within the next few weeks, sending out a pricing survey, probably some sort of a two-tier model where, I'll separate, if you're just an individual, a hobbyist, there will be a lower pay grade, so you can afford it. But if you're using it for commercial use, then probably a bit more, because hopefully your company can pay for it. And I want you, the most important thing is that you're honest, because, lower estimates, for me indicate, that, all right, I will have less funding to do this development. But, if these estimates end up being relatively, of a decent size, then I may be able to, develop this product, continually and to, pioneer, very new and exciting areas of non-circular gear development. But, realistic estimates are what will be essential. But don't worry, your estimate is non-committal. It's not a promise that you're going to pay a certain amount. It's just what you estimate, and what, your realistic estimate of what you feel the product is worth to you, what you are, at this point in time, expect to be able to pay. So keep an eye out for an email for a survey. And anyone who does respond and answer the survey will definitely be entered into a random drawing to receive 1 year, at least 1 year free subscription of the next version of Gearify. And possibly it might be more than one person who receives that if they respond to the survey. So please respond, need your input. All right, that's about wraps it up. The key takeaways here: Gearify 2.0, support involute teeth and helical gears as well, which are vastly better for machining applications. It is an ambitious project to create, a robust sandbox editor. Lets you do all the experimenting and analysis of the world of non-circular gearing. It's very, very cool. You will be able to access it on any device with a browser and an internet connection, one account, any device. Estimated that it will release in 2022, midsummer. And please look out for the upcoming pricing survey because Gearify needs your feedback and support to grow. Thank you. Please email me comments, feedback, questions. My email address is here. I find it very motivating when people respond and show their interest and their enthusiasm, even if it's just a casual, like, hey, that's super cool, glad to see it, whatever. I like hearing back because I know people are engaged and, I find it very encouraging and motivating. So please respond. Please, reach out. Let me know what you're thinking, how you're feeling, and what your ideas are and what you want. All right, that just about does it. So signing off, stay safe, stay well, and I'll be in touch soon. Thank you all.